Morning, everyone. I'm Pooja Sharma, and today I'll be taking a lecture on photochemistry, the types of photochemistry reactions which can be photo, as well as photochemical reactions. In chemistry, we study a number of reactions. It can be a photochemical reaction, which can be a thermodynamical reaction, it can be nuclear chemistry, and so on. In photochemistry, basically, as the name itself is suggesting, it is the study of physical and chemical processes which are caused by the absorption of light radiation. These are the reactions which cannot take place in the dark, in the absence of sunlight, or in the absence of any artificial light. The necessary conditions for these reactions to take place is that there should be some type of natural or artificial light radiation. In the electromagnetic spectra, the light radiations which are coming in between 200 to 800 nanometer wavelength generally bring about the photochemical reactions. In a photochemical reaction, we have a principle of photochemistry. When a molecule it absorbs a photon of sufficient energy, E is equal to h nu, it gets excited to its higher electronic state. When a molecule is excited to the higher electronic state, it may or may not undergo any chemical change. If a molecule does undergo any physical or any chemical change in this process, the reaction is said to be a photochemical reaction. So we can say that photochemistry is the study of any physical or chemical effects which is produced by the interaction of light radiations which range from 200 nanometer to 800 nanometer with the matter. Depending upon which type of a change is taking place, we are having two types of photoprocess. When a substance is exposed to any type of light radiations, its molecules they absorb photons of sufficient energy and they get active. While activating, they have to undergo the change because they have to consume that energy. If that energy is utilized in converting the compound into some other compound, it means their chemical nature is getting changed. This type of a reaction is known as a photochemical reaction. But it is not necessary that every time a chemical change takes place. Sometimes the energy of the molecule is lost in the form of heat, or the molecules collide with each other and they lose that energy without undergoing any type of chemical change. This type of a process is known as a photophysical process. So, in photochemistry, we are understanding two types of process. One in which, after a molecule absorbs energy, it undergoes some chemical change. This type of a process is known as a photochemical process. Second, in which a molecule, after absorbing the energy, does not undergo any chemical change, but it gives out that energy in some other way. This type of change is known as a photophysical change, and the process is known as a photophysical process. Let us see which examples we can have. First, let us discuss the photophysical process. In photophysical process, the radiations which are absorbed by the matter does not cause any type of chemical change in them. It can be of two types, fluorescence and phosphorescence. In fluorescence, the molecule after absorbing the light energy goes to the excited state, and after coming back from the excited state, it starts emitting the light radiations instantaneously. If it starts emitting light radiations instantaneously, this is known as fluorescence. But if it starts emitting radiation slowly, then the process is known as phosphorescence. Apart from the emission of light, there is a chance that the molecules which are activated, they can collide with each other. And on colliding with each other, they lose that energy in the form of heat. This type of energy decay does not involve any emission of light, and this type of process is known as a radiationless decay or non-radiative emission. Let us take some common examples of fluorescence in our daily life. You must have seen that while you are going on a road, you see that the side roads, they are painted with a paint, and when the beam of the light it falls on the paint, then they start glowing. On a dark night when you're traveling on a highway, you can see that the sides of the highway or of the roads, as soon as the light radiations, the beam of light falls on them, they start emitting light, and you can know where you have to go and where you can take a turn. This is the process of fluorescence. In fluorescence, the paint material is made up with, it is painted with a material in which the electrons, they absorb the light coming from the beam of vehicle. And the electrons in that paint, they jump from the ground state to the excited state. And when the beam of light falls on them, they start reflecting back the absorbed energy. In reflecting back, they start emitting the light. And you can see the notice board, which is signboard, which is there on the road, or these paints which are on the roadside, they start illuminating. So this is the process of fluorescence in which as soon as the beam of light falls on them, the molecules or the electrons which are present in them, they jump from the ground state to the excited state, and they immediately they start emitting that absorbed radiation. This is an example of fluorescence. Second example is phosphorescence. You must have seen in your houses, small kids, they have toys which they hang on the ceiling, and once you switch off the light, they start glowing. Then they have some radiations which are there in the clock. So you have seen those digital clocks which are shining in the dark. Now, what is the phenomena behind it? The phenomena behind it is known as phosphorescence. In phosphorescence, the molecule or the electrons which are present in the molecule, they absorb the light radiation and they go from the ground state to the excited. In going from the ground state to the excited state, they take the energy. When they are in the excited state, they have to give out that energy. But this energy is given out even when the source of radiation is cut off. Because once you have switched off the lights, you can see that that object is glowing even in the dark. Now the reason for this is, in fluorescence, as soon as the beam of light falls on the object, the molecule goes from the ground state to the excited, and immediately they start emitting. Whereas in the case of phosphorescence, when the molecules absorb the energy and they go from the ground state to the excited state, after going from the ground state to the excited state, they have to change their orientation. They move from the singlet to the triplet state. In doing so, they reduce some amount of energy. And once they go into the triplet state, now they come back to the ground state, emitting the energy. So, phosphorescence is also visible even when the source of radiation is cut off. The difference between fluorescent and phosphorescence is that fluorescence can be immediate. It takes place only when the source of radiation is there. Whereas phosphorescence can take place even when we cut off the source of radiation. In this fluorescence, the mechanism is that the molecules from the ground state go to the singlet excited state and come back again. Whereas in fluorescence, the molecules from the ground state goes to the singlet, and from singlet they undergo intertransition and they interstate transition, and they go from singlet to triplet. And once they come back from triplet to ground state, they start emitting the radiation. The energy which is given out in fluorescence is higher than the energy which is given out in phosphorescence. The reason behind it is that in fluorescence, we do not have to change the state. Molecule or the electron in the singlet state goes to the singlet state of the excited state and comes back. Whereas in phosphorescence, the molecule has to undergo interstate transition. From singlet, it goes to triplet, and in doing so, it reduces the energy. So the difference is that fluorescence stops right after the source of excitation radiation is switched off, whereas phosphorescence, it can continue even after the source of radiation is taking place. This is one reason phosphorescence is also known as delayed fluorescence. Then what is a photochemical process? The most common example of photochemical process is photosynthesis. A compound or a substance which absorbs a photon of sufficient energy, it undergoes a photochemical change. This type of a reaction is known as a photochemical process. Example, the most common is photosynthesis. In photosynthesis, the carbon dioxide which is present in the atmosphere combines with the water vapors which are present in the atmosphere, and in presence of sunlight, the chlorophyll which is present in the plants, it converts the carbon dioxide and water into glucose and oxygen. This oxygen is taken up by us for breathing, and this glucose is used by the plants as a source of food. So photochemical reaction में the starting molecules for the reactants are different from the products. It means they have undergone some chemical change. So another example of a photochemical reaction is formation of hydrogen chloride. If you take a beaker of hydrogen gas and you take chlorine and you keep them together in a dark, even after number of days or even after years, there will be no reaction till the time you are not exposing them to sunlight. As soon as we are exposed to sunlight, their hydrogen and chlorine will combine to their HCl. Thank you so much, friends. This is all about photochemical and photophysical process. Thank you so much.